In our last video, we learned about slope, and this video we're going to learn about rate of change. So we take a look, and we have an internet cafe. The table shows the cost of using a computer at an internet cafe for a given amount of time. So for 2 hours, it's going to cost you $7. For 4 hours, it costs you $14. And when you go for 6 hours, it's going to cost you $21. So find the rate of change in cost with respect to time. All right, let's take a look at this. It says, let me get this, change of cost. You'll notice that cost, well, this is our x and this is our y traditionally, and that's what it is in this case. So the change in your cost is the change in y with respect to time, which is your x. So if you want change of cost with respect to time, you are basically looking at how it changes your slope. So let's take a look. Change in cost. If we do our change in cost, we had $14 minus $7 because, look, 14 minus 7, those are your two y values. Guess what's going to be in the bottom? You got it. 4 minus 2. So let's go to the next slide and look at that. And 4 minus 2 goes in the bottom. Y is on top, x is in the bottom. And so you get 7 divided by 2, which is 3.5. So your change in cost with respect to time is $3.50. What does that actually mean? That means the rate that they're charging you is $3.50 per hour. So when you find this slope, you are basically finding the cost per hour. All right, let's take a look at another one. Let's have you guys try this. The table shows the distance a person walks for exercise. Find the rate of change in distance with respect to time. Distance is your y with respect to time. So they're basically asking you for the slope. Find the change. All right. Pause your video, give it a try. Welcome back. Let's take a look. All right, so we should have, for our y values, this is x, of course, and this is y. So our y values, 3 minus 1.5, and our x value is 60 minus 30. 60 minus 30. 3 minus 1.5, well, that gets you 1.5, 1.5. And 60 minus 30 gets you a 30. Now when you actually divide these, you will find your rate of change to be 0.05, and that's how many miles per minute. Because on top we have our miles, in the bottom we have our minutes, so it's miles per minute. All right, let's take a look at another one. All right, we're going to look at this nice, beautiful graph here. Week of performance and attendance. A community theater performed a play each Saturday evening for 10 consecutive weeks. The graph shows the attendance for the performances in weeks 1, 4, 6, and 10. Describe the rates of change in attendance with respect to time. So what would you say here? This is your first week, and you have attendance of just over 100. Well, let's see, probably about 124, sorry. And on the fourth week, you have 232 attend. So would you describe this as a quick change of attendance? Sure, it went up pretty fast, didn't it? And then it hit a top, and then it started going downhill. So let's take a look at how we would go ahead and describe this. So in the first 4 weeks, 36 people per week occurred. That was your rate of change. In weeks 4 through 6, it went down by 14 people per week. Just using your x's and y's, that's all you're doing here. Your y's are on top, x's in the bottom. In weeks 6 through 10, you got a decrease of 33 people per week. So attendance increased during the early weeks of performing the play. Then the attendance decreased slowly at first, and then more rapidly. See, just a slow decrease, and ooh, that was not a good sign for that play. All right, let's take a look. We're going to skip that. And let's look at this graph. A student commutes from home to school by walking and by riding a bus. Describe the student's commute in words. Okay, this is in time, how long they're walking to school or riding a bus, whatever they're doing to get to school, and this is the distance. So as you see the distance they travel in time, so if you're moving for a certain amount of time and you're moving a little bit of distance here, what do you think they might be doing? I would guess since it's a gradual increase, they might be walking. And then look at this. Their distance isn't changing at all. It's staying right at the same exact level on the distance, so that means they haven't moved, really. Maybe they're sitting around waiting for the bus. Then, from their bus stop, the bus takes off and goes shoop really fast. So they must have been on a bus, because look how fast this is, that they're going from where they are, and the distance goes up very quickly. All right, let's look at what they say. So you can read through this. Pause your video and you can read it. That basically indicates exactly what I was just reviewing. All right, I would like you guys to use this graph. Let's say using the graph in example 7, draw a graph that represents a student's commute from school to home. So think about yourself going from school to home. You're at school, you get on a bus, then you go home. Sorry, I have to pause my video. My puppies are barking. Sorry about that. So pause your video and see if you can create the graph. Welcome back. Let's take a look. This is what your graph should look like. You hop on a bus, and then you walk home. All right. We're going to stop there. Thanks a lot. Have a great night. And